Problem 2, a rational expression. I've given it in factored form, and much of the information can be told from factored form, but expanded form also gives us some information. So I'm going to multiply these out. So the top would be x squared plus 6x plus 8. The bottom would be x squared plus 7x minus 8. First, the asymptotes. You will have vertical asymptotes when the denominator is 0. The function's going to be undefined there. So that will happen when x is 1. So a dashed line labeled x equals 1, and also when x is a minus 8. So another dashed line over here, and again labeled x equals minus 8. You'll have a horizontal asymptote at the ratio of the lead terms. So now I move from the factored form to the expanded form. X squared over x squared is equal to 1, so the horizontal asymptote is going to be the line y equals 1, and again I label it. You are going to have a y-intercept at the ratio of the constants. Now this should be common sense. If you plug in x equals 0, then everything with an x in it is going to disappear, and you'll be left with an 8 on the top, a minus 8 on the bottom, which is giving me a y-intercept at the point 0, negative 1. You will have x-intercepts when the numerator is 0. If the numerator is 0, the whole thing is 0. So I've got it at negative 2, and again at negative 4. So I have the information about the x-intercepts, zeros of the numerator, vertical asymptotes, zeros of the denominator, horizontal asymptote, ratio of the lead term, and y-intercept, ratio of the constants. I'll also put in some information about when it's above and below the axis. Now, if each of these are single factors, then every time I pass through one of them, for example, pass from just below x equals minus 2 to just above x equals minus 2, the entire expression will change from positive to negative or negative to positive. So I'll have a switch at every vertical asymptote or every x-intercept. I know that I have to flatten to the line y equals 1, so I have to start above the axis. At the vertical asymptote, I will be below the axis. X-intercept, I will move above the axis. X-intercept, I will move below the axis. Vertical asymptote, I will move above the axis. So I know when it's above and when it's below. I have 3 different zones to graph. I'll start with the one in the center. As I approach a vertical asymptote, I have to go either to positive or negative infinity, and since it's negative in this portion, it has to rise from negative infinity. It will come up, go through this point. I'm not sure how far it's going to rise. It might rise above this line, it might not. But it will rise up, come back down, go through this point, slide over to this point, and then go back down towards negative infinity. Given the shape of these points, I don't expect it to rise very far. I'll go with a curve that looks something like that. In zones 1 and 3, all I know is that it's above. But if it has to flatten to the horizontal asymptote and then go towards a positive infinity, it must look something like this. It's positive on this side, it flattens to the horizontal, and it goes up towards a positive infinity. Likewise on the other side, it should look like this, coming up to, but not quite touching, the vertical asymptote.